you have $100 to begin with. A game at a casino costs $1 to play, and with a probability 0.5, you win $1. With a probability 1/4, you win $2, and otherwise you win nothing. And I want you to calculate the probability that after 100 play, you have at least $100. Thank you.
Okay, so first thing I would take to solve it is to, I would denote each net gain of each single game to be xi. So xi can have several consequences. So if we win $1 in each game, then the gain will be 1 minus 1, which is 0. And if we win 2, we will gain 1. And if we win 0, we will have a negative gain of -1. So that is because each game costs $1. So this will have probability 0.5 and 0.25 respectively. And let's assume that each game is independent of each other, and the distribution is the same for all. So now let's calculate the expected value of each xi here. So it should be 0, because 0 times 0.5 is 0, and it adds 1 times 0.25 and -1 times 0.25. This will be 0. So the variance can also be calculated, and variance should be basically I will simple it down a little bit. So this so the first term will be 0 times 0.5, and then we add 1 times 0.25 and -1. Oh, sorry, this will be -1 minus 0 squared times 0.25. Yes, this should be squared. So this will be 1/2, and which is 0.5. So now we have 100 games in total. So the net sum of our game will be x1 plus x2 all the way to x100. And notice that this term will have a similar form as CLT's form. The CLT here means central limit theorem. So I will use central limit theorem to approximate the probability distribution of this S. So by central limit theorem, because these xi's are IID, they should follow a normal distribution. Okay, so the normal distribution should have a expectation of 0, because each xi's expectation is 0, and also a variance of 0.5 times 100 equals to 50. So now, if we want to calculate the probability of this thing greater or equal to, because it is net gain, it should be greater or equal to 0. So by symmetry, a normal distribution with 0 mean will always have a a half chance to be non-negative. So the approximation of this probability should be 0.5.
Yeah, great. You get the right answer, and you use the